Over 15 million people annually suffer a stroke, and 80% of those people subsequently experience hemiplegia. One of the most prevalent therapies for hemiplegia is mirror therapy, where patients place their unaffected limb behind a mirror perpendicular to them to create the illusion that their affected limb is moving normally. However, a study done in 2013 highlighted a shortage of therapists in stroke units. Their research indicates that patient-to-therapist ratios have fallen below ideal levels, with only 6 out of 19 units meeting the ideal patient-therapist ratio of 107:1, indicating the challenges in providing adequate therapy time for stroke patients. Therefore, our COGS 200 project integrates psychology and computer science to improve upon mirror therapy by using augmented reality glasses to assist those suffering from post-stroke hemiplegia.
Many researchers have used various technological approaches to improve the outcome of stroke rehabilitation, including virtual, augmented, and mixed reality. However, a study from 2007 indicates that many people who interact with virtual reality experience motion sickness symptoms, including nausea, eye tiredness, and sweating, that can range from minor discomfort to severe reactions. Moreover, a study from 2020 showed that developing a mixed reality system requires specialized equipment like headsets, sensors, and computing devices, which can be expensive and reduce the device versatility. Last but not least, a study from 2019 highlights the challenge of transferring learned movements from virtual to real-world environments due to the differences in sensory feedback, which hinders the application of motor skills in practical scenarios. In essence, while virtual and mixed reality offers promising technological applications in stroke rehabilitation, they pose significant challenges that we aim to tackle with our product.
In terms of using augmented reality as a stroke rehabilitation assistive device, one study developed a game based on augmented reality using a head-mounted display to show the game to the patients and a 3D webcam to track the patient's hand movement. Another study tried an alternative approach, using a webcam as the overhead camera to capture the patient's hand movement and a projector to project the Fruit Ninja game to the tabletop. These implementations of augmented reality as a stroke rehabilitation device lack the device's versatility. Therefore, in this project, we are trying to implement augmented reality systems in glasses and smart gloves.
This project synthesizes clinical psychology and computer science to make and test an augmented reality system. We hope that this system will help stroke recovery by building upon the principles of mirror therapy. Our system has 2 parts, augmented reality glasses and a glove equipped with tracking and wireless signaling sensors. We plan to equip the AR glasses with cameras to map the space around the user and ensure accurate placement of the virtual arm, which would enable a seamless integration of the digital version with the real world. The glasses connect wirelessly to the glove, which is important for making the movements of the user's functional hand match up in real time. With this project, we aim to address the limitations of mirror therapy by giving people recovering from strokes a tool they can use in the hospital, clinic, or even at home while going about their day-to-day lives.
The smart glove has sensors such as inertial measurement units to catch the precise movements of the user's functional hand. This information is sent wirelessly to the AR glasses, which lets the headset display the user's functional hand movements on their weaker side with high precision, making the mirror therapy experience in the AR setting feel immersive. Unity stands out as a good option for making our software because it is well adjusted for AR projects and handle complicated sensor data and has plenty of tools for making interactive programs. One challenge is figuring out how to display movements of part of the arm that the sensors cannot detect, such as the shoulder. Our software uses machine learning, looking at patterns and using past data on how people move and the data it gets from the sensors in real time. With machine learning, our system can guess where the unseen parts of the arm are and how they are moving. By combining live camera data, machine learning, and glove location data, we hope to create a highly accurate, immersive, and smooth model with very few visual imperfections.
In evaluating our product impact, we plan to use 2 approaches. Firstly, we'll assess its impact on patients by doing clinical assessments, partnering with clinical therapists, including the Fugel-Mayer assessment, box and block test, and functional independence measure. Moreover, we'll also run a single-blind, randomized controlled trial design to guarantee the validity of the evaluations.
Last but not least, we also have to ensure that our software works properly by doing required tests, such as edge case testing, which will assess our product's capability when perceiving varying lighting conditions, occlusions, fast motions, and odd gestures. We will also use integration testing, which will assess focus on verifying the seamless interaction between the AR glasses, the glove with sensors, and the software, ensuring that data is accurately transmitted and processed in real time, and simulated scenarios about the software component of the AR glasses. The successful implementation of our product could hopefully increase engagement in therapy, improve accessibility to stroke rehabilitation, and reduce healthcare burdens by enabling home-based treatments. The lightweight and adaptable AR glasses overcome previous limitations, potentially revolutionizing medical diagnostics and treatments.
While our group has diligently attended to every detail of our project, there remain prospective advancements we hope to see in the event of our product's creation, such as reducing latency, extending battery life, and improving user comfort. Throughout this project, our group gathered invaluable insight regarding the possibilities for utilizing augmented reality and machine learning in a medical setting. Innovating within the realm of psychology, particularly clinical psychology, is an incredibly complex task, and making significant advancements in that field will undoubtedly require an interdisciplinary approach that bridges the gap between technology and therapeutic practices.